My name is Julian Krause. I'm a developer at Yelp. I've been there a number of years now, and recently I've been working on helping us move towards a service-oriented architecture, and I'd like to share some of it with you. So Yelp is a company that's been growing for a number of years now. We have over 100 engineers now already and still hiring more quite regularly. So as these are more and more people, communication scales up as n squared. Because the number of communication paths increase. And so a lot of our problems really come down to how do you deal with a lot of developers. And of course, a lot of developers make a large amount of code. So we have started with one web application, and in the main source space, there is 180,000 lines of code, which we just recently changed from tabs to spaces. You might have seen that on Twitter if you follow the right accounts, but this is a very large amount of code we've built over the last number of years, and it doesn't work to scale that amount of code moving forward. And so this sort of increases the time it takes to bring someone up to speed, and then eventually from there release a feature at all, just to figure out who is involved with everything, where the code is. It just keeps growing bigger and bigger with every line of code, every new developer, and so on. And so we're taking a path that a number of people are starting to take in this world, which is we are splitting our packages out into a large number of smaller services. Each of these services will be more self-contained, have fewer developers working on them independently, and speak to each other over HTTP and REST, which all of us understand very well because we've been working at a web company for a number of years. So the goal of this is that each of these should be a lot more self-contained, a lot more freedom, and if you want to get something done, you can work in just one code base that should be an order of magnitude smaller at least, if not many orders of magnitude smaller than the large one, and get it out to people faster, less overhead from code, communication, and so on. So we've been working on this for a while, so we've run into a number of issues, and we've sort of found other ways around it. So this is a ticket from our system, and because we were a monolithic application for a long time, we sort of assumed that everything was running the same thing all the time. And so one of our dependencies was Tornado for a while, and we were trying to upgrade it from the version 1 that we had installed to version 2 to be able to use some of the new features. Because it was a global dependency, we couldn't update anything until we upgraded everything. And this ticket was open for over a year and a half before we finally just gave up and could not continue forward with it any further. Luckily, we found some ways around this so that we didn't have to upgrade anything anymore. So we are using virtualenv now. Now I know I'm showing this thing about how it's doing it wrong, but actually virtualenv, if you haven't been using it, it's something that you really should look into in your Python development. It makes it so that you can isolate away all the additional dependencies of your Python code. This gist here explains a small issue with the normal behavior behind it, where you source a file called binactivate into it. This guy explains a much nicer way, which looks a lot more like bundler or other tools that people have been using, where you can prefix it with a command and run it in the same way. He's trying to get this into the virtualenv source code in the near future as well. So I hope that this happens. At Yelp, we ended up building a version of this idea ourselves, and it's been very helpful for helping us put the complexity of isolating the dependencies into a single binary that we can hand out to all of our developers and use it. And I've been working on that a lot personally, so if you have any questions about it, feel free to ask me at the end or after the talks. We've also, as people have mentioned in the previous talk, Docker is another tool for isolation. We're currently doing some early investigation of it, and they've been very promising about what Docker could do for our own development processes. And we think it's really exciting because while virtualenv can isolate all the Python stuff, if you have a C extension or you depend upon a C library, it doesn't really isolate you from that, and you still have some further dependencies there, but Docker can sort of take you all the way out. When it comes to actually specifying dependencies for our services, we're now using pip for all of the Python installation. Again, this has been sort of the updated version of all of the installation stuff. If you're using easy install, please stop and use pip. Big also benefit of using pip is you have wheels. Wheels have also been pushed a lot recently, and they are a built package format where rather than having the pip used to download the tarball and then compile it on the fly, wheels are now built ahead of time, and there are some issues involving with trying to make sure that your binaries are lined up. We've been able to get a lot of success and reduce the amount of time it takes either a developer or deployment from wheels to be very, very small of all the installation, even for projects with a large number of dependencies. So that's been very successful for us as well. Finally, we've been using requirements files for maintaining all of this as part of pip as well. And the biggest lesson we've learned from this one is make sure that you always use specific versions in your thing. You always use the equal syntax. There's a great post on caremad.io which explains the differences between abstract and concrete dependencies that I also highly recommend you look up about how to do this. Another thing that we learned is originally we were sharing libraries through submodules, and if anyone's used Git submodules, they're not the greatest tool for anything. So we eventually moved over to a new process where we have separate repositories for everything, and we release a library on a regular basis. We built a tool which looks for Git tags in the repository, and when it sees a Git tag of a new version, it sends it over to Jenkins, and Jenkins will then put it into PyPy server, which works a lot like our existing PyPy server and the existing PyPy server on like py.python.org, and allows pip to interact with it in a correct way. We're investigating some stuff now to have the tagging be after the test and some other stuff like that. Look forward for some stuff of that in the future. Finally, the big thing in the room is what did we actually end up writing all this code in? As I mentioned, we were originally writing all of our services in Tornado, but we have discovered there was a number of issues involving testing and development practices of it, and so we eventually switched over to Pyramid for a lot of our services, and that's been a very successful migration, and we haven't had really many issues with Pyramid at all compared to what we were having before. And so it's highly recommended. If you, again, have any questions about that, feel free to bring it up or go to the talk to me at the end. So before we move down the stack, let me be handing off to another, my coworker here. Does anyone have any specific questions for sort of this higher end of the stack about what we've learned or other things? So the question is about why didn't we not use PEX? So we're not talking about putting these things into like a single file. I'll definitely be interested in looking at PEX since I just found out about it. What I'm more talking about is the actual development process of a developer using a virtual env in their environment and how they get to use that. We definitely are interested in something that allows us to distribute things like that, and so I'll definitely be looking at that. So thank you very much.
Okay, thank you. So now I'm going to take us down the stack and look at some of the stuff underpinning what Julian talked about. So we have the web framework. That's great. It has to actually run on something. You know, we've taken, or we're in the process of taking a lot of the code out of our monolithic Python application. 180,000 lines of code. Bit by bit, we're moving it out. So we have our web framework, we have our code. What's it running on? And there are a lot of choices here. There is the way of GUnicorn. There is also ModWizG if you want to go the Apache route. There is Circus, which is the Mozilla way of doing this. There's Waitress. And there is also UWizG. We chose UWizG after an evaluation process. I'm going to share a little bit of what we were thinking about then. It's not necessarily the one true way. There are other choices you can make. It's working well for us. So what did we look at when we were trying to evaluate what to run our code on? So in pictogram form, one of the most important things, so the Leaning Tower of Pisa, is our code has to stay up. Stability is really important. Nobody wants to wake up at 2 o'clock in the morning because their code has gone down. From bitter experience, it's not a nice place to be in. And USD has worked very well for us. We've been running it in production for a number of months now. Many services are running on it, and it's working well. So next is speed. This old racing car, is it fast? I don't know. USD is fast for us. It's not a good place if you have to change out your application server because it's not fast enough. USD is written, a lot of it is written in C, and we have had 0 performance problems with it. So next is documentation. It's really nice when a coworker asks you, how does this option work? To be able to say, look, there's a load of really good online documentation, go and read it. We've been very happy with that. And then moving on to logging, this is a log ship apparently from a long time ago. It's nice to be able to integrate your logging output from your application server into your standard way of doing logging. So at Yelp, all of our logging goes into Scribe. Scribe is nice and stable for us. It works very well. USD has a way of piping its logging output, so things like backtraces, into the Python logging world, and from there it goes into Scribe, and so we have a real-time view of what errors are happening, and also a historic view onto that as well. Moving forward, community. Community is very important. A number of times I've emailed the USD mailing list, with how do I do this? Or I'm running into this problem. I'm running into this resource limit. How do I increase the number of sockets I can use? And they've always been very responsive, so that's been very good for us. And finally, reloading. So we do, I know this is a Python meetup, but we do also write Java code. And for our Java applications, mainly in the area of search, so Lucene, all of that stuff, we do have proper rolling restarts. We're working to getting that over to our Python world, but in the meanwhile, you can do this hot reloading in USD without dropping traffic. And this is very important for us because it's embarrassing if we're dropping requests whilst we're reloading code. And so USD has a way of doing that, providing your code reloads fast enough, actually. So there is like this caveat, but it actually works pretty well for most of the things we're doing. OK, so moving on. So I don't know how many of you have actually been supported production code, hands in the air. Right, a fair number of you. So a question that often comes up is, what is my code doing? And quite often, you're asking this question at 2 o'clock in the morning. And so these are some questions I have asked myself at 2 o'clock in the morning, and it's great if you can actually answer them. So one question is, what is the 99th percentile time for this endpoint? It's really nice to be able to track performance by endpoint so you know what is happening. Another question is, OK, so things are slowing down. Is it all service instances, or is it just one? Is there a machine that's got slow? We had a problem a few months ago where we had CPU throttling enabled on one of our servers. And this is great if you want to save power. But from bitter experience, it's really bad if you want high performance because the clock frequency keeps going down, and you get spikes in your latencies. And with the system I'm going to describe, we were quite easily able to pinpoint the slow machines and dig in from there. So another question is, how many QPS is this endpoint handling? Maybe another team in the company has decided to start using your service, and so you see a QPS spike, or maybe a bot on the internet is crawling your service. It's very useful to be able to track that. And maybe when you write your service, you're using another service. In fact, quite a lot of the time, that is what's happening. You start to get quite a complicated dependency graph between services. And so it's nice to be able to track performance of dependent services. And once you do that, then there are more sophisticated things to do if a service starts slowing down. But the first thing you want to know is, are downstream services slow? So again, metrics, metrics, metrics. Coda Hale gives an excellent talk about this, and I encourage you to watch it. Another question, so are any clients still using the old API? Quite often we have like V1 of an API when you roll a service out. and then maybe we implement a V2 API in the same service instance. We want to know when we can retire the V1 API, so it's really useful to be able to see how much traffic a given API is still receiving, and then at some point you can delete the code. And users could be external users or internal users. And then finally, did this new service version introduce a performance regression? Ideally, performance always gets better. If it gets worse, then there's something wrong. It's nice to be able to track those metrics. OK, so we want metrics. How do we get there? Well, we could switch everything over to Java. However, that's perhaps not the best idea, given that we're moving Python code out into services. For our Java services, we do use this excellent metrics package by Coda Hail. And what does that look like? Well, for your code, so this looks a bit like Python, apart from it's got curly braces and semicolons. Just try and imagine. So you can create a timer. And then in your handle method, you can create a context manager and basically time how long a given operation takes. And then there's a way of getting metrics out of that from a JSON endpoint in your service. So we thought, this is fantastic. Wouldn't it be great if Python had a similar thing so that you could interactively query your service instances and see what the time looks like? So the nice thing about this as well is that developers can add sort of instrumentation to their code very easily. OK, so we actually wrote this package called USD Metrics that sits on top of USD and allows you to very easily introduce performance measurements. So in this example, we have a context manager, USD Metrics.timing. We give it a name, and then we just run some code. And that is all. And then you can then do a USD Metrics.view to get a dictionary out, which will give you timing information. So what does that dictionary look like? And so we actually expose this via a JSON endpoint on all of our services, so you can very quickly see what performance is. So this is an example of our suggest service that runs on the main site. I think this is a dev instance. But you can see this api.suggest.v1 endpoint. All endpoints get automatically instrumented. And you can see there is this histogram, this timing histogram information with all the various percentiles. So min, max, 95th, 99th, 50th, and also a count. So it's had almost 3,000 requests to it. This is running in dev. As well as that, you can also look at the throughput. So what's the 1, 5, and 15-minute timing doing? And again, same count. And this is very strongly based on Coda Hail's metrics package. A lot of it's ported line for line across. But it's great to be able to have this for Python services. So moving on, in Java world, you have a single process, and it makes it very easy to aggregate data. You have things like shared integers, atomic integers. And so you can have lots of threads, all incrementing integers, and then you can summarize it. That's great. In the Python world, well, especially USD, it's a pre-fork worker model. So you have some number of worker processes all doing their thing. And then you want to aggregate information, metric information, from all of them. And it's great to do this within a single service instance, because you can use the same technique to profile code in dev. Just bring up your service, fire some traffic at it, so replay, and just see what your performance is doing. And then in production, you can run it and have that data going into production monitoring. But how do we actually get there? And so USD has this great concept of mules. And they are processes just like the regular worker processes. They don't handle actual interactive traffic. But what you can do is invoke them using some IPC method, interprocess, blah, 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 with arguments, and it automatically gets serialized, sent across, and we actually have metric summarization happening in the mule. This isn't free. There's a 50 microsecond overhead for recording a metric. 50 microseconds isn't bad. If you're doing 10 metric recordings per request, that's probably OK. If you're doing 100, not so cool. 1,000, it's probably not going to work. But for us, this works pretty well. OK, so that was metrics. Now I'm going to talk about discovery. So what is discovery? So the idea is that you want to bring up a service instance and have it immediately available to handle traffic. If you take a service instance down, you want it to stop receiving traffic. You want to share traffic across all service instances equally, and you want to have good introspection into what is happening. Traditionally, what we did is we actually hard-coded a lot of addressing information. And so you'd have to ticket operations. Hi, could you bring up this service, put it in the load balancer, do a load balancer reload, drop some traffic maybe, not so good. And then you'd also have to put the load balancer addresses in clients. And it all got rather complicated and really extended the time that it requires to roll out a service. And we really want to decrease that time period. And so what we're doing is we're trialing the service discovery technique using something called Smart Stack, which is something that Airbnb have developed. And this is in trial right now, promising initial results. And it really comprises two components. So there's Nerve and there's Synapse. And so I'm just going to talk about this a little bit and show you how it works. So what does the Nerve part look like? So basically, on each service host, there's a single Nerve process. And all it's doing is it's actually querying each service instance running on that host and just saying, are you healthy? Maybe it's a TCP connect, or maybe it's an actual HTTP request. You can configure that. And what it does is it just sends out that sort of health information into Zookeeper. Some of you may know what Zookeeper is. You can basically think of it as a sort of highly available key value store with nice consistency properties. So that's all it's doing. And the nice thing is it scales pretty well because you don't have each service connecting to Zookeeper. We did try this. If you do that, then if you have n service instances, then you have n Zookeeper connections, and you've got to be a little bit careful there. Whereas this, if you have n hosts instead, then you just have n Zookeeper connections. So this works pretty well. OK, so this is how we publish whether or not a service is available. Onto how to use that. So the second component is called Synapse. And what happens there is it's feeding information on a client host into a local HA proxy instance. And clients simply connect to HA proxy and say, hi, I'd like to connect to an instance of whatever service. And it doesn't have to know where the service instances are running. If a service instance gets degraded, it'll fail a health check. And so it'll just drop out. And this is a very promising way. The other nice thing about putting this outside of the actual service layer is that we don't care whether services are Java or Python. We tried developing registration in Java and Python, and it gets a little bit complicated. Here we've taken it right outside. We don't have any problems with threading in Python because Python doesn't have to know about any of this stuff. OK, so using all this information, metrics and registration, you can actually, just as another service, write a dashboard. So this is one of our operations dashboards. And along the top, there are the various environments, so dev environments, stage environments, production environments. They're all blurred out. And then on down the left-hand column, there are the service instances that are available. So we get that information dynamically. There's no static configuration required here at all. If a service is running, it's there. If it's not running, it disappears. We can dynamically, so given the location of a service, you can then dynamically query it for its version, and that ties into our Git repositories. So you can just click on one of these version identifiers, and you can just see what the commit is, the code. And then there's uptime as well, so you can see whether a service is frequently being restarted or whether it's been up for, I don't know, 15 days, 34 days. And then to the far right, that's where you get this metrics information, nicely summarized. There are other dashboards where there is more information. This gives you a nice sort of overview. So for services that are actually emitting metrics, you can get QPS, you can get 50th percentiles, 99th percentiles. And this is really handy to get a very good global view of what is happening. So that's pretty much it from me. Hopefully you've got an idea of what we're doing at Yelp and the sort of problems we're trying to solve. So do you have any questions? So is USD Metrics, that Python library that I showed, open sourced? And the answer is I'm going to be open sourcing it shortly. Are the services in production? Yes, they are. we have some number of services in production for a number of months using this.
And you're using SmartStack in production?
We are not yet using SmartStack in production, so that dashboard I showed you is using our old style way of doing it, where we have Python services directly registering and Java services directly registering. It will be nice to remove that code from Java and Python and have it external. To repeat the question, the mod WSG author is very responsive. Is that true of the USG authors? The answer is yes. So the lead developer is Italian, I think. So at the end of the working day, you can submit your question, and the next day you wake up and it has been answered. So yes, with the time zone difference, it works out quite well. Good question. So do we do anything to document all the various APIs? Julian probably has thoughts on this. So right now, we do actually have a service called Service Docs. And what that does is that when you build a service, all the documentation from that service gets placed on this website and is associated with the service name. So you can go and see all the Python documentation for a given service, or the Java documentation, and hopefully the developers have actually documented their API endpoints. We have thoughts on future ways of doing that, because this is a big problem, right? If you start building services, how do you know what your endpoints are doing? So the other thing we also do is that we encourage developers to write client libraries to actually abstract out the details of the interface. There are definitely pros and cons to that approach. If you're not feeling the pain, you can write bad APIs, right? And then you just slap a nice clean library on top of it and nobody knows that the pain is there. It's a trade-off that we make. We find that almost inevitably people do end up creating client libraries almost implicitly, right? Because you need to interact with this REST service. So in a code base somewhere, someone is going to write a wrapper layer on it, and then you'll have someone copying and pasting that code elsewhere. So we kind of took the pragmatic view of saying, just write the client library in most cases. Right, the question is it important to keep the nerve service on the same server as the services it's monitoring? And the answer is yes, because your failure domain is then the same, right? So if, well, you don't have problems with unreliable networks, basically. So if a nerve process can see the service it's monitoring, then the service is up, and other people should be able to see it. Does that make sense? Basically, it's a good idea to do that because you avoid problems with unreliable networking. Hopefully that answers it to some degree. OK, other questions? Right, so the question is, do we put caching layers between our services? The answer is, right now, we use memcache within services. We haven't, at this point, had to put caching layers between services. The nice thing about using HTTP REST is that there are a lot of options if we need to put caching there. Julian's had some thoughts there.
Yes.
And I think you've been thinking about using Nginx.
Yeah, we've been considering putting Nginx in front of a number of services to try and add caching at that layer in the network to alleviate some of the load onto the services.
Yeah, it's how do we handle security between our services? This is an NSA-style question. It's been coming up a lot. You're probably already in our networks. No, that was a joke. Julian, do you want to answer that?
We are currently investigating some things. The best solution I've seen at the moment is SSL mutual auth. We are investigating that ourselves. And I know that there are some people working on making that easier to do. But if you're looking for that thing, that's what you should be looking at.
OK, it looks like we're done. Well, thank you very much, everyone.